Welcome to Real Civil YouTube channel. In this video, I am going to explain you the how to analyze the truss, in which I am going to explain you the method of joints. Also, I am going to show you how to correctly consider the nature of the force. Okay, so let's start the problem. So the picture is in front of you. This is the truss. These are the joints. This is the first joint A. This is the second joint B, where a 40 kilonewton load is acting. This is the joint C. At joint C, 50 kilonewton load is acting. At joint D, there is a roller support. At joint E, there is a 60 kilonewton load. The span is given. A to E, it is 2 meter. E to D, again it is 2 meter, and it is a equilateral triangle. All the angles are 60 degree. Okay, and we have to determine the forces in the member AB, that is this particular member, AE, this particular member, DE, and DC. So these are the members in which we have to determine the member force. Okay, so our very first step is to draw the free body diagram, or showing the reactions instead of the support. So here you can see there is a support A and there is a support at D, support at A and support at D. So this is the pin support and this is a roller support. Okay, so we have to show the reactions instead of the support. This is our first step. Okay, as we know, pin support, there are two reactions. I have assumed upward RA and horizontal at towards the right HA, and RD vertically upward. Okay, now the very first step is to determine support reaction. Determine support reaction. This is our first step. This is the step number 1. Okay, so we will use, as we know, this is a two-dimensional structure, so we can use summation fx is equal to 0, summation fy is equal to 0, and moment about any point will be equal to 0. So these are the three conditions we can use to determine the support reaction, that is RA, HA, and RD. So that is the very first step. So let's start with summation fx is equal to 0. What does it mean? That means if there are any loads or the reactions which are either towards right, if they are right, consider positive. If they are towards left, consider them negative. Their summation will be equal to 0. Okay, so in our problem, you have to see the reactions or external loads only. Okay, so here there is a one reaction HA which is towards the right direction, so positive HA. There is no any reaction, there is no any external load which is horizontal. Okay, so equal to 0. So I got my first reaction HA is equal to 0. Okay, now next step is summation Fy is equal to 0. Here you have to take upward positive, downward negative, and again same, look for the reactions and look for the external loads only. Okay, always starts from left to right. Okay, so here you can see array, which is upward. Go next. There is one load, external load of 40 kilonewton downward, minus 40. Then here minus 60 because it is downward, minus 50. And then last one is plus RD is equal to 0. So I can write RA plus RD is equal to 150 kilonewton, right? Now I have to use the third condition, that is summation of moment at A is equal to 0. Here clockwise will be positive, anti-clockwise will be negative, and the formula for the moment is very simple. It is force into perpendicular distance. It is force into perpendicular distance. We will take the moment at A, okay? Because HA and RA both are passing through A, they won't get any perpendicular distance. So moment will be 0. Now as I told you, go left to right. Now you have to look for reaction and external loads only. Okay. So here it is an external load. This is the line of action. This is the line of action of the load. And this is the perpendicular distance. So this distance is 1 meter. So I can write 40 is the force into 1 is the distance. And it is making about point a clockwise movement. So I can write 40 into 1. Next, next you will come to E. 60 kilonewton load is there, which is at a distance of a 2 meter from A. Again making clockwise movement. So plus 60 into 2. Now next external load is 50 kilonewton. So this is the line of action, and this is the perpendicular distance. So this distance is 2 meter and this distance is 1 meter. So 2 plus 1, 3 meter. So plus 50 into 3, because again it is making clockwise movement. Now at RD there is an external reaction. So this total distance is 4 meter up to RD, and RD is making anti-clockwise movement about point A. Okay, so minus 4 RD is equal to 0, and we have to solve this. So if you do the calculation, 40 plus 120 plus 150 divided by 4, it is 77.5 kilonewton. So this is my RD. So what is my RA? We know that RA plus RD is equal to 150 kilonewton. We have written here. So from this, I can get RA is equal to 150 minus RD, that is 77.5. So I can get RA. So 150 minus, so I get 72.5 kilonewton. So this is my first step to determine the support reaction. Now RA is 72.5 kilonewton. RD is equal to 77.5 kilonewton and HA is equal to 0. Okay. Now we have to determine the member forces AB and AE. Okay, first AB and AE and both are connected to joint A. So in method of joint, this is very important point. In method of joint, you have to select a joint where there are maximum two unknown forces are there. Okay. So if we select joint A, at joint A, there is a reaction which is Ra 72.5 kilonewton. There is Ha which is equal to 0, right? So there is Ra, there is Ha, and there are two members connected to this particular joint. So this is the first member and this is the second member. So this member is AB, A and B, AB, and this member is AE. Okay. So first member is AB. I will write force in member AB, and second force in member AE. Now we have to assume the nature either positive or negative, either tension or compression, but don't pick the nature randomly. If you see here, this is the complete free body diagram of joint A. Okay, this is the complete free body diagram of joint A. Now we have to solve this joint A using equilibrium condition. Using equilibrium conditions. Okay, if we solve, we can get the force in member AB and force in member AE. Okay, now the force in member AB and force in member AE, as it is a truss, so the force nature will be either tension or compression. Okay, so we have to assume the nature. So how to assume? So here if you see, there is a vertical load of 72.5 kilonewton acting at joint A in this free body diagram. So to balance this, there someone should be downward. Okay, AE cannot produce downward, but AB, the angle is 60-degree here, right? So we have to resolve. Now there must be a downward force to balance this 72.5 kilonewton. Okay, and for this type of resolution, if it is getting downward, then other part of the resolution will go towards the left. So for this type of resolution, we have to assume the nature compression. In AB, we will assume compression in AB. Okay, so this force will become FAB sine 60, and this will become FAB cos 60. Okay, now as there is a force which is going towards left, that is AB cos 60, so to balance this there must be someone towards the right. So we will assume the force FAE like this, that is away from the joints. So I assume tension in member AE. Okay, away from the joint, tension towards the joint compression. Okay, now let's use the equilibrium condition. So first we will use summation Fy is equal to 0. That means upward force is positive, downward force is negative. So you have to apply this for the joint only. Okay, so that's why the free body diagram is very important. So upward is 72.5 and downward is minus FAB sine 60. There is no any other force equal to 0. So FAB is equal to 72.5 divided by sine 60. So it is 83.72. 83.72 kilonewton, and the answer is positive. That means assumed direction of which is compression, nature compression, is correct. Second, we can use summation fx is equal to 0. We cannot use the movement condition as it is a problem of concurrent system. All the forces are passing through a single point. So answer will be 0. So summation fx is equal to 0. Again, towards right positive, towards left negative. So 0 kilonewton don't need to consider. Then FAB cos 60 minus FAB cos 60 towards left, hence minus, and this is FAE towards the right plus FAE is equal to 0. Therefore, FAE is equal to FAB. We know that FAB is 83.72 into cos 60. So it is 41.86 positive because it will go towards the right. 41.86. We have assumed it tension. Answer is positive. That means the nature is correct. So the first force FAB is 83.72 and the second force FAE is equal to 41.86 kilonewton. Okay. Now let's do the process to find DE and DC force. So DE and DC. So this is the DC, this is the DE member. So we have to draw the free body diagram of joint D. So here the free body diagram of joint D. So at joint there is a vertical reaction, right? RD is there, vertical reaction 77.5. Next there is CD force member and there is DE. So we have to show. So I will use other color. Okay. There is one member like this. There is another member like this. DE. So this is the force in member DE and this is the force in member DC. Okay. Now we have to assume the nature of the force. Okay. So again here there is one upward force, right? So to balance this there must be one downward force, and this downward force can only be produced by this inclined member. Okay, after resolution DE cannot produce because DE is perfectly horizontal, there is no any resolution. Okay, so other component I will show like this. So FDC, again this angle is 60 degree, FDC cos 60, and here FDC sin 60. As there is force which is towards right, so I will assume this towards left. That means member DC I have assumed towards the joint, uh, that is tension. Just a minute. That is compression, and DE away from the joint tension. That member is in tension. Okay. So let's check our assumption is correct or not. If answer is negative, we have to correct ourselves. So first I will use the condition summation Fy is equal to 0. Upward is positive, downward is negative. So upward force, you have to apply this for this joint only. So the upward is 77.5 minus there is one downward force FDC sin 60. So FDC is equal to 77.5 divided by sin 60. So 89.48, 89.48 kilonewton, right? And we have assumed this compression. Our answer is positive. That means correctly assumed. Next, we have to use summation Fx is equal to 0. Second condition, towards the right take it as a positive, towards the left take it as a negative. Okay, so this is the towards right, FDC cos 60 minus FDE is equal to 0. So FDE is equal to FDC cos 60. So FDC you have to put here and take cos 60. So 44.74, and answer is correct. We have already assumed it as a tension away from the joint. So that means the nature is tensile. So this is how you can determine the member forces using method of joint. Okay. So in the next session, we will use the method of section. In this, we have completed the method of joint. Next, we will complete the method of section. So if you have any doubt, you can ask me. You can try to determine the forces, remaining forces in the member. If you feel any difficulty, comment, I will reply, or you can post your answers also. I will reply back whether it is correct or not. So thank you so much for watching the video. Please like, share, subscribe the channel. Real Civil. Thank you so much.